Hello and good morning, and welcome to today's Sherpa Funds Technology Process Alpha webinar. What portfolios could you build? My name is Steven Quimby. I'm here with our founder and CEO, Richard Waddington. Thanks everyone for joining us today. Again, if this is your first Sherpa Funds Technology webinar, what we're going to do today is we're going to spend about 25-30 minutes talking about our topic, what portfolios could you build? So if you have any questions, please feel free to put them in the chat at the side, or we will take questions at the end. Also, if you have to jump for any reason midway through the session, we will have the replay online on our YouTube channel probably later today. So with that out of the way, what are we going to talk about today? So this is a topic that is kind of near and dear. It's important to us at Sherpa. It's something that it might be a little bit nerdier than some of our usual topics, but what we're talking about today is how we generate the portfolios that you could build for use in our candidate portfolio analysis and other tools that we use to help PMs better understand their sort of impact of their portfolio decisions. So today we'll take a quick introduction. We'll talk about why this is a unique problem, why this is something that most people don't do, and they don't think about it, so they don't necessarily think about the challenges that go into creating a universe of the possible portfolios you could build. We'll talk about the space, so how you can understand which possible portfolios you could build. This is, again, it's a fairly mathy problem, but we want to try to map it down into a manner that makes this really practical for PMs to sort of apply in their day-to-day. And then we're going to talk about methodologies that we've been working with here at Sherpa to try to expand on how we can better cover that space and how we can produce a better sample of the possible portfolios you could build. And then, as we said, we'll do Q&A at the end, or if you have anything, feel free to jump in midway. So broadly speaking, what we're doing today, this is something that Richard, the Sherpa team, the Sherpa R&D team is spending a lot of time thinking about, and it's something that we've developed multiple iterations on. And this is, how do you search and how do you quantify the possible portfolios you could build given a set of asset selections and a portfolio shape? And we've talked about portfolio shape before as constraints. We've got other webinars. We won't go into that in as much detail today. But generating this universe of possible portfolios you could build is critical to a lot of the analysis that we do here at Sherpa. This is the backbone of how we perform our candidate portfolio analysis, and this is the backbone of how we build out our manager's scorecards that we use for sort of managing the ongoing process. And so today we're going to talk about how the sausage gets made, if you will, how you can go from building this sort of abstract universe of possible portfolios to using it to actually improve your process. So this is something that, we've never talked to a PM who, prior to talking to Sherpa, thinks about their portfolio in this way. This is something that's not, most PMs find it fairly intuitive, actually, once you sort of explain to them the concept, but it's not something that most PMs are used to looking at. And so in our view, if you don't know the things that you could have done, you don't know how good you were versus how lucky you were at being on a particular path. And so the whole purpose of building the universe of possible portfolios that you could have created is to help provide some real clarity around what was the impact of my asset selection? What was the impact of my portfolio construction? What was the impact of the objectives and constraints? And did that put me in a set of possible outcomes that is acceptable, that's sort of in line with what I'm expecting as a PM? If not, which parts of the process could I change? Which could I improve to put myself in a range of possible outcomes that's sort of in line with what I'm supposed to be doing with my fund? So again, these are things that we've talked about in more detail otherwise, but today what we're really going to focus on is how do we actually build this universe? So if we think about the core building blocks, right? First, you have the asset universe. So what could you invest in given your mandate? Then most PMs spend the vast majority, a lot of studies would suggest 90% of their time thinking about their asset selection. So from that universe, which assets, which stocks do you want to own? And then the next step is thinking about what is a portfolio that's compliant with my organizational requirements and compliant with my style and my objectives as a PM. What are the objectives and constraints that go into building my portfolio? Now, if you think about the asset selection and the objectives and constraints, the combination of those two defines the portfolios that you could have created given a certain set of assets subject to a certain set of constraints. And so when we think about that, this is something that we find very powerful. We find this a very important concept because this universe of possible outcomes, this is going to illustrate the spread of possible results given your alpha, given your asset selection. It's going to quantify how much alpha was really possible given your set of constraints. I mean, maybe you say, okay, well, how much better could I have done? And maybe it's not that much because your constraints were so tight that, you sort of had a fairly narrow range of possible outcomes based on the constraints and your asset selections. So we also want to understand how, Richard, I think we're a slide behind. That's okay.
Oh, sorry.
We want to understand how those objectives and constraints impact that range. Does that tighten the range? Does it make it wider? Does it shift it up? Does it shift it down? And the next step then really is once you know how your asset selection is driving the range of possible outcomes and how your objectives and constraints are making it wider or narrower and moving it up and down, how good are you within that range? How good have you actually been at portfolio construction, position sizing in terms of finding a good outcome within the range of possibilities? And by doing all these things, and this is something we've talked about again in detail on our scorecarding and sort of managing the process webinar, this allows you to build feedback loops from that quantified alpha, from that quantified range of possible outcomes to look at your asset selection and your portfolio construction and determine how good you are. So this is critical to building that process. Fundamentally, it's a fairly difficult process. It's difficult because there's a large number, very large number of possible portfolios you could create, and it's kind of non-intuitive. So Richard, I'm going to let you walk us through how do we build the universe of possible portfolios? How do we solve that problem to produce an informative universe that helps PMs practically make better decisions?
Yeah, thanks, Stephen. The issue of trying to find the full universe of possible portfolios is one with two big problems. Oh, I'm sorry, there's a doorbell ringing in my background here. I'm going to have to tell them to just go away. Okay.
Well, I can drive while you tell them to go away.
You drive. Can you drive the screen?
Let me go ahead and I'll talk from this screen. You tell them to go away, and I'll talk from this screen. So broadly speaking, as we were saying, this is difficult because of two main problems. One, the number of possible portfolios is very large, and two, from this huge set of possible portfolios, and then a much smaller set of portfolios that actually satisfy your objectives and constraints, you need to find a sample that covers the space of possible outcomes, but it's very difficult to intuitively understand what that space looks like. So these challenges, like we say, number one, there's a large universe of possibilities, and number two, understanding how well you're covering that universe of possibilities is a very difficult thing. And so when we talk about the large universe of possibilities, if we just start with a sort of simple two-asset example, that simple two-asset example, if you have two assets, minimum of 20%, maximum of 20% in increments of 10 basis points, already you have 600 possible portfolios. And this is just two assets. And obviously, if you're an active PM, maybe you hold 50 assets, 60 assets. But even starting at two, you already have a non-trivial number of portfolios. And as we expand on this, if we take this to three assets, if we take this to four assets, we can see that the number of possibilities explodes very quickly. And so, Richard, let's talk through the math. How does this explode?
Well, apologies for that, everybody. The issue that, as I was saying at the beginning, right, there are two big issues. The first one is the number of possible solutions to the portfolio problem is huge. And we said two assets with that very tight constraints. You had 600. It's not very big. You had this third asset, and even with this very artificially simple portfolio, you end up at 80,000 possible portfolios. So you've already moved from something which is easy to visualize and 600 portfolios you can imagine in an Excel sheet, 80,000, at which point you're like, quite hard to see what's going on. actually, as you increase we know how many possible portfolios there are for a very simple problem set. So if you just use integers, so everything has to be a whole number of percentage points, you end up with this formula. And we won't go into it, but the point is that at 5 assets, the number is around about 5 million. And every asset you add, the rate at which that number increases also gets bigger. So at 6 assets, it's about 16 times that, and 7 assets, it's about 17 times that. And even that 16, 17 isn't linear, it progresses. It's not actually exponentially, but it progresses in an increasing manner. So the problem of saying I've got a portfolio definition, I've selected a bunch of stocks or bonds or currencies from a possible universe, how many ways could I build that portfolio, becomes one of increasing computational complexity as you add assets. Now, it's not just the number of assets that makes it complicated. It's actually the fact that in the real world, a portfolio is not a simple thing of I've got 5 things and I want to have a bit of each one. In the real world, the kind of clients that Sherpa deals with, the institutional clients, have real world constraints on what they can do. And maybe they are benchmarked to something, so they need the subsector weightings to be within certain ranges of the benchmark. Maybe they need individual assets to be constrained because of liquidity, because of how much they can actually buy or sell. There may be, compliance issues with certain stocks, the number of stocks, and then you have the sort of desired outcomes, which is how much of your weight is in your higher conviction versus your lower conviction. Maybe you have factor constraints, maybe you have ESG constraints. So when you add all these things together, suddenly not only is the range of number of possible portfolios huge, you've got 50 assets or 80 assets, something like that, but the permitted combinations becomes very, very complicated. It's no longer a simple thing of saying you've got a space of assets and anything in that space will do. There are little bits that work and there are areas that don't work. You've both got a big number of problems, a big number of possible solutions to your problem, and typically a very small subset of that very big number that is actually permissible under the objectives and constraints that you're working under. So you have this problem of it sort of lives in 2 different ways. The actual number of solutions you can hunt for is huge. I mean, more than the number of atoms in the universe, right? When you get to like 100 asset portfolio. But the number of portfolios which are actually permissible within that huge range is quite small. So how do you find permissible portfolios? And remember, the whole purpose of this is to say, what are the permissible portfolios that you, an institutional asset manager, can hold that expresses your alpha? And that's only by knowing what you could have can you say both how good have you done and how good is your alpha. So I mean, I'm kind of in a very simplistic way say, reiterate this, if it's just 2 assets with very simple constraints, you can see the permissible range on the left-hand box. You say, okay, I've got 2 assets, A and B, and I must have between 90 and 100% invested, right? So I can have up to 10% in cash. So the permissible range is the blue stripe on the left. Then when you start adding these constraints, you can see the shape of the permissible range changes. And you may say, well, is that real? And of course, actually, this sort of oddly shaped constraints happen all the time. Like I must be able to liquidate 80% of my portfolio in 10 days, and the other 20% I can liquidate over 6 weeks or whatever. Plus the sector constraint, et cetera, leads to permissible regions of the searchable shape that are not continuous and that are odd shapes. And this is just a simple 2D example. you can imagine if we're doing this in 40 asset space, you can imagine that it's extremely hard to work out what you're actually allowed to have and what you're not. And if you think about that in the practical way in which portfolio managers actually do this, how is the way that portfolio managers typically, when they don't use a sort of Sherpa type approach to service, how do they construct their portfolios of risk? It's a lot of trial and error. Oh, I like this one a bit more, I'll add a bit of this. Or what has that done to my risk? What's it done to my liquidity profile, my cash ladder, my sector biases, my factors? Oh, it's done this. Okay, then I have to do a bit of this to tweak that. And in general, you can imagine like the method of constructing a portfolio by tweaking, which I guess is the sort of standard way of doing things, right? Take an idea, tweak until you can kind of get compliant with everything, is that's not going to be the best answer, right? It's going to be an answer. It's not going to be the best answer. And again, the purpose of this approach, this candidate portfolio approach, is to see within the universe of possible answers, how good or how bad was the answer you arrived by tweaking. So in order to do that, we have to have an assessment of all the possible compliant portfolios. How much space do they occupy? How do you find them? And again, there's two real issues. The first one is there's so many possible portfolios. The second one is so many are not compliant. So how do you assess whether you've found a good set of possible portfolios? And particularly, it's a 40-dimensional problem if you have 40 assets. And things, typical, traditional or intuitive concepts such as, this portfolio is like this portfolio because it has, a couple of assets that have changed weights, swapping one from the other. So that idea of distance, right? This portfolio is similar to this portfolio. Actually, once you get into higher dimensional problems, the concept of distance becomes incredibly difficult. What does distance mean in 40 dimensions? And we won't, not going to go into that, but that's the kind of, these are real problems that, physicists think about all the time in physics issues, and there are real problems in portfolio construction. So that leads us back to, well, how do we worry, or how do we not worry about these complexities? I mean, we at Sherpa are an intensely practical organization. We're really not concerned with the theoretical issues of 40-dimensional distance. We're interested in the practical outcomes of different portfolio constructions. And that leads you to the thing saying, well, actually, the right way to look at portfolios, possible portfolios that could be constructed, is to look at the lived experience of constructing those portfolios. And the lived experience of owning a portfolio of risk assets is, in fact, the P&L that portfolio generates over time. So by switching your mindset from worrying about the theoretical difficulties of 40-dimensional space and distance and corner cases, and thinking that actually, let's flip ourselves into the frame of reference, which is P&L. I mean, P&L is simple to calculate. You've got asset weights and you've got market data, and you can create P&L stream for a possible portfolio. So, you've got a portfolio. Over time, it generates a P&L stream, and that P&L stream can generate or can be simplified into 2, 3, 4, 5 numbers, whatever things you care about. But typically you'll look at the return, you'll look maybe at the volatility, the drawdown. Maybe you'll look at upside vol versus downside vol, Sortino, CalPERS ratios. It doesn't matter. We're not going to go into what's the right one to look at. It depends on who you are, who your LPs are, how you've set up your business, what matters to you. But the point is that you've taken this 40, 50, 80-dimensional problem and reduced it down to something which you can express very simply. A portfolio generates a return stream which can be assessed relative to other return streams in a very simple manner. So we've we had one portfolio, now we create 4 different portfolios from the same assets within the same compliant constraint set, and they get different return streams. And you can see here, I mean, this is an illustrative example, but you can see, you get a higher return, but you get a higher vol and a higher drawdown. So some portfolios are riskier than others. Some are expressing the alpha better than others. Some have more propensity to drawdown than the others. But they're all valid, and they're all portfolios that exist within the space that you're searching for. Now, the point of this really is to say, okay, if we assess every possible portfolio that we can find that fits, we can get an idea of what is the value of the alpha in the asset selection, both in terms of how much average return does this alpha generate and how much breadth of possible outcomes could that same asset selection give you. So clearly, if you have looser constraints in what you can do with a set of assets, you'd expect the green lines, each of which represents a portfolio, to be wider spread, and for tighter constraints, it'll be tighter spread. If your alpha is more positive, you'd expect it, higher bottom left to top right, and if your alpha is less correct, or your asset selection is less correct, these graphs will be flatter. But the point again is that we've gone from worrying about this as a 40-dimensional problem into something which is much more visualizable and much more relevant, and it's something you can talk about with your clients, with your colleagues, because it's the real thing you experience as a portfolio manager. But we come back to the core question is like, well, how do we know that the portfolios that we generated here actually cover the sample space? This is the crux of the matter. Right? We've said there are a lot of possible portfolios, and there are not that many which are compliant, and they're quite hard to find. So we have we covered the space? Do we have a good representation across the space? Is our selection spread in the same sort of way that the real world would say? So is our sort of density of portfolio samples correct? And have we reached the kind of outliers where there might be a possible compliant portfolio where asset A is 5% and all other possible portfolios of asset A at 3%? So when you're searching, how do you ever find that one with asset A at 5%? And we need to work out whether we've searched properly, whether we've searched thoroughly enough and broadly enough to be confident that the analysis we're driving, the things we tell our portfolio managers, actually is valid and will help them. So how do you search a 40-dimensional, 80-dimensional constrained space? You can, the kind of jargon is like, you've got some sort of hypercube, n-dimensional space with lots of funny corners that are cut out of it, etc. How do you actually search this space? Well, there are actually lots of ways. They're generally called constraint satisfaction problems. And we don't really want to get into the massive detail because that's not much fun for any webinar participant. But just to give you a broad overview, you can do Monte Carlo, so throw random darts at the dartboard and see what sticks. You can use evolutionary algorithms, so starting conditions, and let the algorithm evolve into something which fits. Or you can do, and actually this is our sort of latest line of research, which prompted this whole webinar, SMT, satisfiability modulo theorem maths. There are many other ways, but we just want to kind of brush over these because they're 3 different ways, 3 different sort of approaches to life, which have lots of offshoots which you can try in different manners. Monte Carlo actually doesn't really help. Once the dimensionality gets above 4 or 5, the probability of getting a compliant portfolio from a random sample drops off a cliff, and the compute cycles required to get anything that remotely covers the space, just shoots up, and you're going to gum up your computer forever. So we actually sort of use Monte Carlo in some ways to create starting conditions, but we don't use it to try and get to a solution. Evolutionary algorithms are interesting, and actually we initially used the EA approaches to create sample portfolios. They work, but because of their nature, because they're typically aiming for some objective function which drives the answer to some point in the sample space rather than to spread across all samples in the sample space, you get answers, but you don't get a good spread. SMT is something we've actually been developing for the last 4 or 5 months. And SMT turns out actually to have some very powerful tools, powerful methods for creating broad spreads of portfolios and searching relatively efficiently. Without going into too much detail, and I'm not going to claim the credit for this, but our R&D guys came up with this stuff a few months ago. The joy of SMT is the way that you can express these constraint problems in very, very low-level computer languages, which are, these are things which were designed back in the 70s, these very low-level computer languages, but they have the ability to do what they call very functional programming which doesn't require things to happen in steps, but gives you answers irrespective of how you start. Without going into any more detail, but it works, and it's pretty clever. So how do we, well, it works, it's pretty clever. How do we know it works? It's pretty clever. The way, again, we come back to looking at how does our spread of possible portfolios evolve? How does it express P&L of a portfolio over time? So we know if we've covered a wide range. So, this is a portfolio. Each green line is a possible, this is a set of assets with a set of constraints, which is what drives or defines a portfolio, and each line is a possible solution to that problem. And with our old evolutionary algorithm method, we get this range of portfolios. And the point is that as you increase, as you move away from EA into the SMT methods, you suddenly start seeing, you're finding more outliers. Now, the fact that the second graph, the graph on the right, has these low P&L return streams, those are portfolios which the EA would never find. And exactly why I wouldn't find, you could sort of back engineer and try and get into that, but that's a very tedious and unrewarding piece of work. But the fact is that we know they don't find them. So these SMT methods, because we can create different starting conditions, and the way that SMT operates, you end up with the starting conditions which force you into wider range of possible portfolios and force you to find the corner constraints or the corner solutions more easily. And again, without getting, we kind of don't really want to get into the too technical stuff, but time and time again, we see how we've gone from like the simplest possible way of finding portfolios to the EA approach, which give us the blue graphs, to the SMT approach, we get where the green graphs are. We see consistently that we're getting wider range of possible outcomes in portfolio return space, which infers the fact that in the n-dimensional hypercube, we're getting a wider range of possible outcomes and a broader sampling of the corner cases. So that says it's doing its thing. And how do we assess whether we're approaching a solution that we should be happy with? Well, you can, and this is relatively common sense, but you can say, okay, let's try it with a certain number of compute cycles, a certain number of range of starting conditions, a certain protocol for cycling through starting conditions, and see how broad a range of P&L outputs do you get? So if we, and this graph is, we've taken one of the stats, which is the 90 percentile spread. So the spread between the lowest 5 percentile and the highest 95th percentile return stream. And say, okay, let's see how wide does that become, or how much wider does it become as you increase the compute cycles and the starting condition protocols. And actually the result you get for that particular portfolio we just showed is the blue line, which sort of asymptotically approaches, I guess what's the number on there? It looks like it's approaching around about 7.5%. The red line is just a log graph, so you get an idea. I mean, theoretically, it kind of should be like a log result, but you don't really have a proper theoretical answer because of all the way the constraints interact. I mean, it's not a solvable problem, or you can't say it is definitely a log thing because of whatever the constraints, how they interact. But this real, practical experiment plots the blue line, and that lets you say, actually, is there any point going from 200,000 to 1 million compute cycles? Well, maybe it's worth going from 200,000 to 400,000. Is it worth going from 400 to 800 or 1 million? Maybe not. It allows you to say how far along the the asymptotic curve of perfection do you really want to go? Where do you want to stop? It's telling you very clearly under 200,000 you haven't got anywhere near enough information. Over 600,000 or 800,000 you're probably wasting time. You should be doing something else for that time. So returning kind of back to the point again before I hand back to Steven, the purpose of this whole thing, and we did a couple of webinars on this in the past, and I think the links will all be in the video and the discussion. The purpose of this is to say, for a portfolio manager who has a specific set of assets they've selected and a specific set of objectives and constraints that they're working to, what is the possible set of outcomes they could achieve? This graph, just to show the thing, this is actually a real live portfolio from last year. The portfolio manager achieved the red line in this case. The portfolio manager could have achieved with his same set of assets and objective constraints any of the green lines. So there is clearly some alpha in his selection. It wasn't luck that he made whatever it is, 2.7%, 2.4%, sorry. But with better portfolio construction, and that's where it comes back to what Sherpa does, you'll get the light blue line. You will do better. The better set of portfolios that you can try and see how they go, the better that you will be able to assess both the amount of alpha and how good your portfolio construction is. And that's the whole point. And that's where Sherpa comes in.
It's something where the methodology of expanding our sample. I think I've got echo. But the methodology of expanding that sample is one where the outliers, so if you were to look at the graphs that we had carefully, and if we were to look at some of the statistics behind those distributions, you'd see that they tend to have the same direction. And when we've run the numbers, more often than not, these different methodologies produce very similar averages. But there are very real outliers. If you stumble into, as a PM, the first percentile, 0th percentile worst possible outcome, how bad could that be? Or if you just knock the cover off the ball, if you have the absolute best outcome, how good could that be? And so if you have that sample where, like Richard said, you've only gone through 100,000 compute cycles and you're sort of at the beginning of that logarithmic curve before it starts to taper off, and you think that your spread of possible outcomes is 5%, and actually your spread of possible outcomes is 7.5%, that's a pretty big difference. And so the way that, for us, it's important to think about that and quantify that, because as a PM, one of the big parts of that portfolio construction decision that we've talked about asset selection, and then objectives and constraints. If that band is wider than you're comfortable with, you maybe need to be thinking about the latter part of that, thinking about your objectives and constraints. And so by building this better sample, it gives PMs more information. It gives you a better understanding of how your asset selection and objectives and constraints interact to drive your portfolio's performance. And so this quantifying the space better and understanding the space and making sure that the sample is a good representation of what PMs could create is fundamental to performing this type of candidate portfolio analysis and providing this feedback to fund managers in terms of how good they are at their asset selection, how good they are at their sizing and construction, how their constraints are impacting things. So this is something that we're always working on improving. Like Richard went through here, we've had multiple methods that we've used in the past, multiple methods that kind of work together in different manners for the way that we construct this sample of things that you as a PM could do. And it's an area for continual improvement here with the Sherpa R&D team. So I think, we're going a little bit over time, but just broadly speaking, we have a lot of other resources around this idea of using this universe of possible portfolios, the things that you could do to answer the questions: how good is your asset selection? How good is your portfolio construction and position sizing? What's the impact of your portfolio shape? And then how does that track over time? As a PM, are you operating in a trading envelope that you're comfortable with? Are you producing the alpha that you expect to produce? And is there room for improvement in your portfolio construction? And so this analysis is fundamental to answering all of those questions as a PM. And so we have more resources. If you joined us late, we will have this video as well as all of the other resources we've talked about today on our Process Alpha YouTube page. We'll also have resources at sherpafundstech.com. But if you want to learn about how this works, if you want to learn about which portfolios you could be building from your set of alpha, by all means, reach out, get in touch. Sherpafundstech.com. You can email any of us, give us a call. Richard, any last comments before we sign off for the day?
No, thank you very much, everybody. Thank you, Steven, for putting this together as ever. And no, please do get in touch. Very good.
Okay, great. Well, so thanks everyone for taking the time today. Again, if you'd like to see the slides, if you want to talk about it, just reach out and we're happy to provide that. Otherwise, we will see everyone next time.